It's amazing, but it looks like a team of scientists have announced an incredible new theory that will make it a lot easier to answer the question of whether there is life on other worlds. NASA's upcoming Nancy Grace Roman Space Telescope will enable these scientists to identify exoplanets out there in the universe, which could even mean planets that are similar to our own Earth. With this new discovery fueling a lot of discussion about other habitable worlds, you won't believe how the Roman Space Telescope will find habitable exoplanets. First, you're probably wondering, what is an exoplanet? Well, exo comes from the Greek word meaning outside or external, and so an exoplanet just means a planet that is outside our solar system or outside our sphere of knowledge. As we know, the universe is so unimaginably colossal that even the scopes and scales of what we do know are incredibly vast. Space scientists are used to this sort of scale though, and their work is often focused on just trying to find more information about what is out there and how it relates to our existence here on this planet. So it is then that their latest research is going to make it a lot easier to find these planets. The Nancy Grace Roman Space Telescope, or NGRST, is a NASA infrared space telescope that is currently being developed and is scheduled to launch by May 2027 at the latest. These scientists have posited that it will be able to measure a very specific kind of space dust that is spread throughout dozens of nearby planetary systems' habitable zones, or rather, the regions around stars where elements come together in mild enough a manner that liquid water can exist on worlds that orbit said stars. It's clear that such a thing would enable them to find out how much of these materials are contained in other star systems, which would be of enormous help to our astronomers who want to learn about how rocky planets form. It would, of course, also enable the better search for habitable worlds by future missions. When we look at our own solar system, zodiacal dust, which is represented as tiny rocky speckles that are left behind when asteroids and comets collide and crumble, is all over the place. It can be observed from close to the Sun all the way to the asteroid belt between Mars and Jupiter. If you were to look from a distance, as we must, zodiacal dust is then the brightest thing in the system besides the Sun itself. It is this same dust that creates an obscuring miasma that makes it hard for us to see the planets in other systems. It is scattering the light of the star itself. Ewan Douglas, an assistant astronomy professor at the University of Arizona in Tucson, says that if we don't find much of this dust around a particular star, that means future missions will be able to see potential planets relatively easily. But if we do find this kind of dust, we can study it and learn all kinds of interesting things about its sources, like comets and asteroids in these systems, and the influence of unseen planets on its brightness and distribution. It's a win-win for science, as the NGRST will make it possible for us to see this dust wherever it may be found. The search is an extremely promising example of the potential for the device. The thing is that by studying the zodiacal dust, or in fact, exozodiacal dust, being as it is outside our own system, astronomers will be able to find clues to traits other planetary systems have. The debris and the amount of it will give us an idea of comet activity in an area. Since the more dust there is, the more asteroids and comets there are likely to be. Seeing the distribution pattern of the exozodiacal dust will also enable us to access the probable locations of exoplanets, as their gravity would affect this distribution. The deputy project scientist on the telescope, Bertrand Menison, says that no one knows much about exozodiacal dust because it's so close to its host star that it's usually lost in the glare, making it notoriously difficult to observe. We're not sure what Roman will find in these other planetary systems, but we're excited to finally have an observatory that's equipped to explore this aspect of their habitable zones. The NGRST could use its onboard coronagraph, an instrument that blocks out light from the Sun's actual surface and allows scientists to observe only the corona, to observe the coronas of other host stars in different systems. This is something that would let them make sensitive measurements of the light reflected by the system's exozodiacal dust. Douglas says that it's very hard to block a twinkling star, and this is certainly the case for most ground-based telescopes. John Debs, an astronomer at the Space Telescope Science Institute in Baltimore, said that the Roman coronagraph is equipped with special sensors and deformable mirrors that will actively measure and subtract starlight in real time. This will help provide a very high level of contrast, 100 times better than Hubble's passive coronagraph offers, which we need to spot warm dust that orbits close to the host star. This is certainly true. as while the Hubble Space Telescope has been able to observe cold debris disks far from their host stars, no one has ever been able to photograph the warm exozodiacal dust in the habitable zone region. It's fascinating to consider because one of the things that we are always asking in science is whether or not there's any evidence to suggest other life out there in space besides us. Of course, statistically, it is extremely likely that somewhere out there in the vastness of the universe, another species of comparable development to humanity would exist. But in what environment and how? Plus, as human beings, we are infused with an unyielding curiosity about things we cannot see or understand. We have to answer the question for sure, and the NGRST is going to be a big step forward in this effort. While previous NASA projects have had some success in preliminarily measuring the exozodiacal dust in habitable zones, the Roman's images will be infinitely more sensitive thanks to the advanced high-contrast coronagraph instrument and also its stable location in space. The telescope will be orbiting 1 million miles from Earth, around what's called the Lagrange point 2, or L2, instead of in low Earth orbit like Hubble. This means that our own planet will not present such a challenging environment from which to observe the dust in other systems. Getting accurate images of the warm exozodiacal debris closer to host stars is absolutely crucial to the effort because it is made up of different material entirely than the outer dust disks. Closer to a host star, rocky grains are going to make up the vast majority of the dust, while, as you might expect, the further dust disks are mostly made of ice and icy grains. The debris differs greatly based on its proximity to host stars and is created by totally different processes. So getting to understand the chemistry of exozodiacal dust is going to change everything, allowing astronomers to obtain info they would not have had a hope of getting any other way. They simply can't understand what happens in the center of the debris by studying the outer regions around other stars. Debs added to his previous statement, stating that, by prospecting for this dust, we could learn about the processes that shape planetary systems, while providing important information for future missions that aim to image habitable zone planets. That is huge, because future efforts will be made all the simpler thanks to Roman. He added further, saying that, by finding out how much exozodiacal dust is in the way of possible planets in nearby systems, we can tell how large future telescopes will need to be to see through it. Observations from the Roman coronagraph could offer a crucial stepping stone in the search for Earth's analogs. Incredible news then, because of course, while we might not be able to reach them, or even have a hope of any one person reaching one in their lifetime, the knowledge that there are in fact other Earths out there would change our perspective about everything. Imagine if you actually knew that there is another Earth besides ours. That would make it extremely likely that there is another human race, if indeed that's the way their evolutionary history has gone. The NGRST, or just Roman, represents a massive leap forward in science's ability to understand the formation of the universe, the arrangement of other star systems, and the likelihood of us having a comparable species out there somewhere. It's going to change everything about everything we know about space, life, evolution, and ourselves. But what do you think? This is Space Infinity. For more earth-shattering reports, click that like button and subscribe. Thank you for watching, and see you in the next presentation.